Welcome back to Python for Scientific Computing 1. In the last two videos, I gave you an overview of Google Colab and Jupyter Notebooks, the environment that we will be using to execute Python programs. In addition, we've also talked about data types and data structures, which are the fundamental basis for storing data and memory management in any programming language. What we're going to do today is put all that we have learned together into a hands-on exercise. So we're going to do a few computational tasks, and with the idea that we can see how we can start writing code in Python. Okay, so without further ado, let's jump right in and see how we can use Google Colab, Jupyter Notebooks, and to solve some simple problems using Python. Here are the 5 problems that we will be solving today. These are fairly simple, but our goals is to see how these basic mathematical operations are performed in Python, and also give you some practice with using HTML and LaTeX for text formatting in notebooks. In particular, if you look at formulas such as those shown in problem 2 or in problem 4 that involves numerator, denominator, square roots, and such, you can make them look really pretty just like this using LaTeX. So that would be what our focus will be. In addition, we will also be looking at the math module, which is a library that will provide us with performing the functions, mathematical functions such as natural log, sine, cosine, that is needed for problems 3, 4, and 5. Once we go to Colab, we can put a new notebook. And when we open a new notebook, you're going to see that it shows us some of the old codes that are available here, or things that you have opened in the past, notebooks that you've opened in the past. What we want to do is get a new notebook. So I'm going to get a new notebook. And we see that we've got a notebook that is titled Untitled 0 PYNB. IPYNB stands for Interactive Python Notebook. I'm going to go ahead and change the name of this notebook. I'm going to rename this as Exercise 1. Okay. And as soon as I rename, it'll start saving the file. So you can see that it is saving, hit enter, and then it'll save the changes. To make, instead of going back and forth between my problem set and Google Colab, what I've done is created an image, a PNG image of the problems that we're going to solve today. So our first step, what I'm going to do is import that image into the notebook so that we have all the problems that we want to solve at one place. So to do that, I'm going to include a text box, and I'm going to move it up because that's where I want it. And then I'm going to double click on it, and so that I get into the edit mode. And once I get into the edit mode, here's an image. So I can click on this image and it opens a file that I can upload that is on my computer. So I have here a file called exercise1.png. This is the image file, and I'm going to upload this. This PNG file is available to you in the GitHub repository that I have put for this course. So I open this PNG, and you can see that it has put some things that is essentially its rendition of the PhD. So this is the file behind the details, but if you keep scrolling down, you will notice that the PNG has been rendered down below. So what I can do is I can simply go to the text box and get out of the edit mode. And once I do that, all I'm left with is rendition of the final version, which is my exercise. So once I have this, I can also add another text box here, and I can add what is known as a horizontal ruler. So the horizontal rule is simply three dots, as you can see. And once I add this, either I can turn off the edit mode or I can hit Shift Enter, and it draws a line there just to separate things out from what we want. So our first problem, and then I'm going to add another text box right after that, right here. And here I'm going to essentially put my first problem. So I'm going to write problem 1. So rather than that, before that, let me do heading 2. And I'm going to put a font of color is blue. And then I'm going to say solutions, okay? And I'm going to close out the font because that was the last tag, and then close out H2. And then if I hit Shift Enter, it just simply shows me the solution and hides the edit mode. Once I have this, I'm going to add another text box. And in this text box, I'm going to be simply putting problem 1, and I want this to be bold, so I can just go and click on this bold here, and you can see that bold simply is 2 stars. So if I put the markdown for bold is simply 2 stars. Anything that's enclosed between 2 stars shows up as bold. And then I'm simply going to retype the problem that I have above, add 2 to 3, and divide the resultant number by 4, print the result. So this is my first problem. So I'm going to again Shift Enter. I get the problem, and now I will start coding. So this arrow sign here in the gutter, in the left gutter, tells me that this is a code cell, so I can start coding in this cell. So the first thing I want to do is I want to define A is a variable. So some variable, you can name it anything you want. I'm going to name it name. And then I'm going to add 2 plus 3. So what has happened is I've added 2 plus 3, right? And if I run this code, it will connect to Python and run it, and really nothing happens because Python has executed and kept the result in a variable called A. We have not printed this A. So let's go ahead and print A. All right. So if I do this, now if I scroll down a bit, you can see that A is equal to 5. But that's not what I want. I want the resultant number to be divided by 4. So again, what I'm going to do here, this is something you will see quite a bit in numerical analysis, is we reuse some of these variables. So I say A equals A divided by 4. So this sometimes is a source of confusion for students, but the thing to keep in mind is that the A that you're seeing on this right-hand side, the one that I just highlighted here, is the value of A before this calculation is being made, okay? And then, so basically, initially it was A is equal to 2 plus 3. So I took that A, and then, which will be the value of 5, this highlighted A will have a value of 5. I'm going to divide that by 4, and then I'm going to rewrite that back into A. So basically what I'm doing here is take the previous value of A, which is equal to 5, divide by 4, and rewrite back into A. Okay, so, and now you might say, well, once this is done, I can now execute it. You still see this A because I have a print A here. Now I'm going to say print the resultant value is, and then I'm going to put A. So the result, it will print me the resultant value is 1.25. So the intermediate value of A was 5, but now the value of A is 1.25 because I took that 5 divided by 4. Okay? So when you see A on left-hand side and right-hand side, keep in mind that whatever the value, previous value of A is there, that will show up on the right-hand side, and then whatever you manipulate, you're going to scratch out, you're going to erase that um, whatever was in A before and rewrite new values. So we have our first problem done. So the second problem is we want to compute this following expression. Compute the following expression, 2 cubed divided by 3 plus 2, the fourth root of 16. So I'm going to go ahead and put a text box. And this time I'm simply going to say problem 2 and then close it. So you can see it has become bold. I'm going to put a colon, and then I'm going to say the expression that I want to compute is 2 cubed in the numerator, 3 plus, so 2 cubed. So problem 2, evaluate. And I want a numerator, denominator, so I'm going to start using LaTeX here. To use the LaTeX inline, I'm going to put $, and then I'm going to say frac. Frac is a very convenient LaTeX function. The reason it is very convenient is because it gives you stuff to put in numerator and denominator. And in the numerator, I have the number of 2 cubed, so I can simply put 2 raised to power 3. Notice that in LaTeX, we mostly use flower brackets. Sometimes we use square brackets, but it's a lot of these functionality of LaTeX comes enclosed within flower brackets. So that is my numerator. The second box is for the denominator. And in the denominator, I have 2 items. One is 3, and the second one is 2 times fourth root of 16. So I'm going to put 3 plus 2 times. Now I want the square root. So I'm going to put SQRT for the square root symbol. But I want this to be the fourth root. So I'm going to put a square bracket and put 4. And then I want to put a curly bracket or a flower bracket. And in there, I'm going to put 16. Okay? And when I close this, it renders. And of course, sometimes it says, are you a robot? So if you're slow, it keeps checking that you are not a robot. Okay. Again, if I want to hide this edit mode, all I do is I hit Shift Enter. So this is my problem. So this problem has got a numerator and a denominator. So whenever there is a numerator and a denominator, what I do is I simply say, I first make the calculation of the numerator, which is equal to 2 raised to the power 3. Python uses 2 stars for exponentiation. So I'm just going to make a comment here and say Python uses 2 stars for exponentiation. Okay. So that's my num. My denum is equal to 3 plus 2 times 16. So 1 star is simply multiplication raised to the power of, so I want the fourth root. So the fourth root is 1 divided by 4. Okay. So again, I'm using the multiplication operator, the exponentiation operator, and then an addition operator. So that's my denum. And then my final expression, exp, we'll just call it E, equals num divided by denum. Okay, and then I want to say print the expression. Of course, I need this in quotes. Evaluates 2, and then I'm going to put value So if I run this, what Python does is it runs the first line, computes the numerator, then computes the denominator, then it computes this e, which is numerator over denominator, and then finally prints this text followed by this number, which is being shown here. All right. So whenever you have fractions, complicated fractions, it's best for you to do the numerator calculation and denominator calculation separately. Of course, we could have written all that into a single formula, and that temptation is high, but you avoid making errors if you break down the calculations and do them in a piecewise manner. So let's move on to the third problem. So for that, as I said, from problems 3 onwards, I need to import the math library. But before this, I'm going to go put the text, and I'm going to put my problem 3. And my problem 3 states, I want to compute e raised to the power of natural log n. So essentially, I want to compute, again, I need an e. This is e as in e raised to the power of, again, I'm going to put a flower bracket associated with that raised to the power and put natural log of 10. And I'm going to close this dollar sign. And again, if I do the shift enter, it'll hide and just show me the text. Okay? So here I'm going to be using some mathematical functions such as the exponentiation and the natural log. To do that, I'm going to import the math library. So import math. So Python by itself doesn't have all the mathematical functionalities built in, but it puts all that mathematical functionality into something called a module, and we bring that module, and that's how we make all these functionality available to us when needed. So here I got this import math. So once I import math, I'm going to calculate the exponential part. So I'm going to call p, and actually I can do the whole thing. It's fairly simple. So I'm going to say b, some value b, some variable b is equal to math.exp. Remember, the exp is not a built-in function, but it's a class that is coming out of the math library. So you have to say math.exp. And similarly, I want the natural log of 10. So again, that is coming from the natural, so I put 10. Notice that log in Python math module is natural log, not log to base 10. So typically, sometimes we write, to make that distinction, we write ln to mean natural log, but keep in mind that log in math module is natural log. And as you can see, every time I'm talking, I'm making some documentation using this hash sign. So this is what is known as the comment lines. Comment lines are extremely important, especially when you're beginning. You tend to avoid it. You'll say, well, what's the big deal? But putting those reinforces your brain to learn what this syntax stands for, and also makes it easy for others to see what that syntax stands for. So here's math, and this is math module for accessing math functions. All right. So, and then of course, it will just, as you guessed, it will make that calculation, store it in the value of b. So I'm going to print, and then I'm going to say the value b is b, and it will then write to the console saying that it's 10.00000002. Now you might be wondering why this 2 is hanging out right here, because if I take the natural log of a number and then raise it to the power e, I should get back that number, right? That's what math tells us. So I should technically get back 10, but instead I'm getting 10.0002. This happens because numbers in computers are not stored use as decimal numbers like we do, but as binary numbers as 0 and 1. So sometimes there is, and it can only store so many zeros or so many decimal places. So there is going to be some round off errors and truncation errors that come into play. And this is again something very important when you do numerical analysis, because let's say I do a several billion calculations on this number, this tool will eventually creep all the way to the left and get and start affecting this number. So round off errors, truncation errors, or numerical errors are something that we have to be aware of. And this is a simple example that illustrates that to you. Okay, but for all practical purposes, as an engineer, you would say, well, 10.0000, all that 2 that I'm seeing here is practically equal to 10. So the next expression that I'm going to be doing is the sine 2x divided by square root of cosine x plus e to the power of minus x. And I want to compute this at a value of x is equal to pi by 8. Okay, so what I do is I go back and I put my problem 4. So I need a text box. So I put a text box, again, 2 stars, and say problem 4. Close that with 2 stars so it's becomes bold. And now what I want to do is I have a numerator and a denominator. The numerator has sine 2x. So if I want numerator and denominator, I need to use LaTeX. So I'm going to use LaTeX. And you guessed it, the function, the LaTeX syntax is to put that frac. That's the numerator. That first flower bracket is for the numerator. The second flower bracket is for the denominator. And I need sine 2x. And then here, I need square root. So this is square root straight to the power 2. So I don't need to, I can just straight use square root. And cosine of x at x equals another frac. Here I need pi, and here I need 8. So I need to calculate this at x equals pi by 8. Again, if I hit shift enter, now I have my complete problem. So the first thing I'm going to do is I'm going to say x, define that value of x. X is equal to math.pi divided by 8. So I've defined my x. So my numerator now is equal to math.sine 2 times x. And the x again refers to that variable x. And then my denum, my denominator, is equal to math dot cosine of x. And of course, I want this in a square root, so I'm going to put math dot sqrt, math cosine x, plus math dot exp minus x. Okay? And then I'm going to say my resultant, which I'm going to store in f, is equal to num over denum. And then I'm going to say print the expression when I run this, you'll see that this is what the expression about. Now let's say I don't want to carry all these, I just want to keep it to 3 decimals. All you have to do is you have to say round f comma 3. So round is another built-in function that you can use to round up the final numbers that you're getting here. Now we come to our last problem. So let's do a text box again here. And 2 stars, you got it. Problem 5, colon. We want to check whether sine square pi by 8 plus cosine square 2 pi by 16 is equal to 1. Notice that 2 pi by 16 is nothing but pi by 8. So sine square pi by 8 plus cosine square pi by 8 should be equal to 1. So that expression should render itself to true. But let's check that. Okay, so that we can use a Boolean type function here. So to do that, we'll go back and say evaluate whether, um, again, sine square, and here I put a frac because I want pi by 8 plus cosine squared to pi by 16 is equal to 1. Okay. And I close my dollar sign. It gives me sine squared pi by 8 plus cosine squared 2 pi by 16 is equal to 1. This is what I want to evaluate. So I am just going to hit Shift, Enter. There's something that didn't render correctly. That's because there is a space between two stars. So remember, when you put two stars, don't put a space. You will have to put the whole thing right next to it. Okay? So Shift, Enter, and now we have this problem. So for this, again, I'm going to first define my x. X is equal to math.pi divided by 8. You see that 2 pi 16 is also x, but I'm going to define another variable called y and say math.pi, or 2 times math.pi divided by 16. All right. And now my expression, I'm going to store the left-hand side of the expression. I'm going to call it LHS is equal to math dot sine x, and I want this whole thing squared plus, so because sine squared is nothing but sine times sine, math dot cosine of y, and I want this square, right? And my RHS is equal to 1. That's, and then I'm going to check LHS equals RHS. Okay. Notice the double equal for comparison. Since we use equal to for assignment, we use double equal to in Python for comparison. So now if I do this, I see that LHS is equal to RHS, which is the last thing that got computed, came out to be true. So first I computed the left-hand side, then I define my right-hand side to be equal to 1. And then, so once I have my left-hand side and right-hand side, I say, is the left-hand side equal to right-hand side? And when you get that, you see that this is true. The key takeaways from this exercise was, first, we saw how to import a PNG image into a Jupyter Notebook text box. I also showed you how to close the edit mode of the text box using Shift Enter or by pressing the Close Editor button. We also saw how we can use combinations of text and code boxes to document and write code at the same place within the Jupyter Notebook. In addition, we learned a few HTML tags. More importantly, we learned how to put headings. I show you an example of a tag for heading 2, but you can use the same thing for heading 1, 2, 3, 4, and others. I also showed you how to change the font color. The tag for the font color, you put font space color equals, and you put the name of the color in quotes. I also showed you some markup, especially the markup for making your text bold was to just add 2 stars. Don't leave any space after the stars so that Otherwise, it won't render correctly. I also showed you how to enclose formulas using dollar signs for LaTeX typesetting of mathematical formulas. And in particular, we saw the latest LaTeX function /frac, which is used to put fractions where there is numerator and denominator. We also saw how to put a square root, which is simply /square root in flower brackets x. And if you want to put any other power, for example, cube root or fourth root, what you do is you still use the square root command. You just put /square root sqrt. And in square brackets, you put the number, for example, for fourth root, you would put 4, and you would put the number n in curly brackets. Uh, we also made use of the math library to access some math functions in Python. In particular, we looked at log, we looked at exponential, sine, cosine. Anytime you're using functions from the math library, you have to put math dot, the function name, so that it knows which module to get that class or that function from. Also keep in mind that the math library in Python uses log to represent natural log. If you want log to base 10, then you use math.log10 instead of math.log. So I hope you found this video useful. I will see you in the next lecture with a few more Python concepts. Till then, take care and goodbye.